Hello, this is Dr. VC Sontake, and I am the course faculty for the course Energy Conversion 3. The objective of this video lecture is to define and explain various performance terms of gas turbine and gas turbine plant and their significance. So let us discuss various performance terms related with the gas turbine and gas turbine based power plant. The very first term is the cycle air rate represented by AR. Now, in case of gas turbine, thermal efficiency is a measure of fuel economy. However, the size of the plant is equally important in many applications where the gas turbine based plant should be compact, like in the field of aviation. So the size of the plant depends on the flow rate of air in relationship to the useful power output. Air rate is defined as the air flow required per kilowatt hour output. Thus, air rate is the ratio of mass of air required to produce per unit kilowatt hour output. Air rate can be given as m dot A over kilowatt hour output, where m dot A is the mass flow rate of air. Representing kilowatt hour output in terms of m dot A into network output in kilowatt hour kilojoule per kg. So simplification of this will give me air rate as 3600 divided by network output in kilojoule per kg. So air rate can be given as 3600 divided by network output in kilojoule per kg, and unit will be kilogram of air per kilowatt hour. The reciprocal of this air rate is termed as specific power. Significance of this air rate. Air rate is actually the criterion of the size of the gas turbine based power plant. That is, lower the air rate, the smaller of the plant, gas turbine based power plant. The next performance parameter related with the gas turbine is cycle work ratio WR. Now, a good design of gas turbine not only requires high thermal efficiency to increase the fuel economy and low mass flow rate of air for a small size of the power plant, but it must also have high work ratio. The work ratio WR is defined as the ratio of net work output to the turbine work. Mathematically, it is given as work ratio is equal to the ratio of net work output to the turbine output. Significance of the work ratio. From the above equation, it can be shown that for a good gas turbine, the work ratio should be high. The work ratio may also be used as a guide in the determination of the size of the gas turbine and as an indicator of the sensitivity of the plant to the component efficiency. If work ratio is high, the size of the gas turbine will be smaller. So we can decide whether to produce given amount of network output, what will be the size of the gas turbine by calculating work ratio. Next parameter is specific fuel consumption. It is one of the most important parameter and expressed in kilogram of fuel per kilowatt hour. A specific fuel consumption is defined as the amount of fuel required to produce unit work output. So a specific fuel consumption can be given as 3600 into m dot f, that is mass flow rate of fuel in kg per second, to the net work output, and unit will be kilogram of fuel per kilowatt hour. This can also be given as 3600 into ratio of mass flow rate of fuel to the mass flow rate of air to the net work output in kilojoule per kg. The next performance parameter is back work ratio. Back work ratio is defined as the ratio of compressor work to the turbine work. So back work ratio can be given as compressor work to the turbine work. The significance of the back work ratio is that less will be the value of back work ratio, less work input will be required by the compressor, and net work output will be increasing. After watching this video, you will be able to define and explain various performance terms of gas turbine and gas turbine based power plant and their significance. With this, I come to an end of this video lecture. Thank you for your kind attention and passionate listening. Happy learning.